In this video lecture, we will go through corrosion of metals, right? So corrosion of metals is simply defined as reaction of metals with atmospheric components, that is water vapor, oxygen, carbon dioxide, right, when metals are exposed to air. Or we say that when metals are exposed to air, the surface of the metals are attacked by the components of air, right? So reaction of metals with components of air, components of air like water vapor, oxygen and carbon dioxide, right? Or attack on metal surface by air components. This is your simple definition of corrosion. Now let's understand it by taking some examples. When a pure reddish brown copper metal is exposed to air, what happens is, when this is your copper, this is your reddish brown in color when pure, in pure state. So when copper is exposed to air, it will slowly start acquiring a green coating, or you see a green deposit on the surface of copper metal, which is due to basic copper carbonate, because copper reacts with water vapor and carbon dioxide to form basic copper carbonate, which is green in color, right? So here, when metals react with components of air, they form different chemical compounds, right? Due to formation of these chemical compounds, metal will lose their original luster and shine, right? So due to corrosion, metals lose original luster and or shine, right? Similarly, if we talk about silver, silver will react with traces of hydrogen sulfide which is present in air to form silver sulfide, right, which is black in color. That is why people who wear silver jewelry, after some time you will see that the jewelry will start acquiring black color due to corrosion of silver, and when silver gets corroded, it will form a chemical compound silver sulfide which is black in color, right? Similarly, if let's take some other example. Let's take example of iron, right? Iron will react with oxygen and water vapor in air to form hydrated ferric oxide, right, which is brown in color, right? We will also understand the corrosion of iron based on electrochemical theory, right? So this brown colored metal we know is known as brown colored compound that gets formed on the surface of iron when iron is exposed to air is known as rust, right? And this is very common example of rusting, because many materials that are made up of iron, you will notice that they will start acquiring brown color when they are exposed to air because of rusting of iron, because iron when exposed to air will get attacked by oxygen and water vapor to form this brown colored compound which is known as hydrated ferric oxide, right? Now, why do these reactions takes place? Because metals we know by nature are reactive in nature. So when metals are exposed to air, they will start reacting with components of air. And why they are reactive? Because we know that metals have 1, 2 or 3 electrons in their outermost orbit, which they can easily lose out to other substances or other atoms, ions or molecules to form compounds with them, right? So metals, why does corrosion takes place? Corrosion occurs because metals metals are reactive by nature, right? So that means if the reactivity of metals goes down, the corrosion will inhibit, or corrosion of metals will come down. That is, metals that are less reactive have less chances of getting corroded, or they get corroded very slowly, right? For example, if you remember the activity series of metals has sodium, potassium, calcium, magnesium, iron, zinc, right? And if you come down, you have gold, right, at the bottom, right? And we know that gold doesn't get easily corroded. Why? Because gold, being a very less reactive metal, it doesn't react with components of air, right? So that is why people who wear gold jewelry, the gold jewelry doesn't get turned into something called some other compound, or we say that gold doesn't acquire any other color when exposed to air, because it doesn't react with the components of air like silver does. So silver jewelry will acquire black color. Why? Because silver, being reactive metal, will react with hydrogen sulfide to form silver sulfide, whereas gold, which is a least reactive metal, it doesn't react with components of air even if it is exposed to air for 100 years. Right? So as the reactivity of metals will go down, there would be less chances of metals get corroded. Similarly, one important corrosion is corrosion of aluminium, which reacts with air to form Al2O3. And we say that aluminium doesn't get corroded. Why? Because aluminium will react with oxygen to form aluminium oxide, and this sticks to the surface. Sticks to aluminium surface and stops further corrosion. How does it stop further corrosion? Because it acts as a barrier between the surface of iron and air. This aluminium oxide will form a coating on the surface of aluminium, so it doesn't let oxygen come in contact with the surface of aluminium. Hence the corrosion of aluminium will stop. Right? Since this is a stickable material, it sticks to the surface of aluminium and stops further corrosion. In case of iron, this ferric oxide is a porous material. When it forms, it falls off from the surface of iron, hence exposing the below layers of iron to further corrosion. So formation of this brown colored rust will promote corrosion, whereas formation of aluminium oxide will inhibit corrosion. Now let's quickly understand corrosion of metals based on electrochemical theory, since now we are studying electrochemistry. Now when we talk about electrochemical theory or electrochemical reaction, in electrochemical reaction we have anode, right? Then we have cathode, then we have electrolyte, right? So let's see how we can adjust these three things in rusting of iron. Right? To understand rusting based on electrochemical theory, we will take example of rusting of iron. Suppose I have taken this bar of iron and exposed it to outside air. You know, in air we have water vapor. So you will see a deposition of water vapor on this surface of metal. We know that oxygen and carbon dioxide are soluble in water. Right? So since iron has water, oxygen and carbon dioxide will dissolve in water vapor. Right? So now this oxygen and carbon dioxide is in contact with this surface of iron. Now since this is water vapor, we know that carbon dioxide gets dissolved in water vapor, so there would be a reaction. Water vapor will react with dissolved CO2 to form carbonic acid, and we know that carbonic acid is a weak acid and will further dissociate feebly or weakly to form hydrogen ions and carbonate ions, right? So this is the reaction. So here we need to have electrolyte. So solution of this solution of carbonic acid will act as electrolyte, right? Now we have hydrogen ions. Hydrogen ions we know are good electron acceptors, so hydrogen ions will act as electron acceptors. We'll see this in a moment how, and will promote the corrosion of iron. We'll see how. Now since this iron, right, is in contact with this dissolved oxygen, right, and now it is in contact with these hydrogen ions also, so iron will react with will undergo oxidation in presence of oxygen and hydrogen ions, right? Iron, this is the bar of iron. It is in contact with oxygen, which is an oxidizing agent. It is in contact with hydrogen ions, which is again an oxidizing agent. So there are two oxidizing agents, right? So iron will undergo a reaction in presence of dissolved oxygen and hydrogen ions, and the reaction is known as oxidation reaction. Since we know that iron is reactive by nature, that is, it can easily lose out its electrons, right? So iron, here we'll take second example, second reaction. So iron in presence of dissolved oxygen and hydrogen ions will lose 2 electrons to form ferrous ions, right? This reaction is your oxidation reaction, right? And we know that in electrochemical reactions, the site where oxidation takes place, that site is known as anode, right? So on this surface of iron, the site or the places where this reaction will take place, those sites are known as anodes, right? So sites on surface are known as anodes where this reaction will take place. And we know that in electrochemical reactions, when electrons that are lost at anode, they will migrate to cathode and will undergo and will cause reduction. So these electrons will migrate, right, to another site and reduce this dissolved oxygen, right, in presence of hydrogen ions, right? So these electrons, right, will migrate, say, to some other site, and will cause reduction of, since electrons can cause reduction, right, they combine and reduce other substances, so it will cause reduction of oxygen in presence of hydrogen ions. We know that hydrogen is an electron acceptor, right? So hydrogen ions will accept electrons and will reduce or combine with oxygen to form water. Electrons, this would be third reaction. Electrons will travel or migrate to reduce oxygen in presence of hydrogen ions. Oxygen will react with electrons in presence of hydrogen ions to form these electrons. These electrons would be accepted by hydrogen ions, like this. Hydrogen ions will accept electrons to form hydrogen atom. So similarly, 2 hydrogen ions will accept 2 electrons to form hydrogen gas, right? So it will form hydrogen gas, which will react with oxygen to form water, right? This will react to form water. So it will form water. Since here reduction is taking place, these electrons are accepted by hydrogen ions, right? So this is known as, this reaction is your reduction reaction. And we know that in electrochemical reactions where reduction takes place, that site or that portion is known as cathode. So where this takes place, it's known as this, the sites where this reaction will takes place, that is known as cathodes, right? So now we have ferrous iron due to this oxidation reaction, and we have water due to reduction reaction. And one more thing, this hydrogen ions will act as a catalyst in the corrosion of iron, or in the corrosion reactions, or in this electrochemical reaction. Hydrogen ions will act as a catalyst, because without hydrogen ions this reduction reaction will not take place. If this reduction reaction will not take place, the entire reaction would not occur, right? So these hydrogen ions will promote corrosion, right? Or we say the environment where we have more hydrogen ions, the environments are acidic environments, right? So where we have pH less than 7 or acidic pH, right, in those solutions or in those environments, corrosion of iron is promoted, right? So where we have less hydrogen ion concentration, or pH value is say 9 to 12, their corrosion is very less, or the corrosion of metals will not occur if hydrogen ion concentration is very less, or pH of the solution or the environment is more, say 9 to 12, right? So hydrogen ions act as catalyst, right? So now we have ferrous ions, right, in presence of dissolved oxygen, or ferrous ions reacts with dissolved oxygen to form ferric oxide, right? From here we have ferrous ions, right? Ferrous ions gets formed on the surface of this metal. We have water vapor here, right, and we have dissolved oxygen in water vapor. So ferrous ions will react with oxygen, right, from air, or which is dissolved here, to form, in presence of water, to form Fe2O3, right? This is your Fe2O3. Now this Fe2O3 will undergo hydration. This will undergo hydration, that is, it will combine with molecules of water to form hydrated ferric oxide. It will combine with X molecules of water to form hydrated ferric oxide. This is your rust, which is brown in color, and it's a porous material. It will fall off from the surface of iron, hence exposing below layers of iron for further corrosion, right? So this is your electrochemical theory. Based on electrochemical theory, we have explained corrosion of metals. So here anode is the site where this oxidation reaction has taken place, and cathode is the site where this reduction reaction has taken place, and your electrolyte is solution of carbonic acid, right? And I hope all this is clear to you. And one more thing, presence of electrolytes promotes corrosion, or we say corrosion is promoted in saline water, the water that contains dissolved salts, right? Suppose if a water contains dissolved sodium chloride, it will promote corrosion, because electrolytes contain ions, and these ions help in the movement of